Now we'll discuss about dimensions and principle of homogeneity. Now, first of all, what is the dimension of a physical quantity? The dimension in physics means the physical nature of a quantity. Now, what's that? There's a chance you might confuse the word dimension with unit of a physical quantity, but they're different. Let's see an example. Like when you say about distance, distance can be expressed in different units. In SI, the unit is meter, and in CGS system, the unit of distance is centimeter. But if we say about the dimension of distance, now that is just length. And we express the dimension, length, is the customary practice to use a square bracket and put capital L inside that. This is the dimension of distance, while the unit may be meter, centimeters, and so many other ways also, like kilometers, anything, millimeter, so many types of units are possible here. Let's go for the next thing. We remember in mind that there are base quantities. So let's know the dimensions of them first, a few of them. Similarly, go for mass. The unit of mass can be kilogram in SI and gram in CGS system. In FPS, that is called pound, and the symbol for that is LB. Now, the dimension of mass, once again, you put a square bracket, and within that you put capital M. Now, this is the dimension of mass. So you see that dimension and units are quite different commodities, but it's possible to know one, to derive one of them if the other is known. That's really helpful. Next, we can talk about time, the next base quantity. Time can be in second, millisecond, anything, but writing dimension of time, just you put a capital T within square bracket. Temperature, the next base quantity, thermodynamic temperature, it can be expressed in so many units like degree Celsius, degree Fahrenheit in FPS, and of course Kelvin. That is, you can see that this is Kelvin, capital K, and there is a chance you might confuse it, but when you talk about the dimension of temperature, you put in square bracket a capital K there. So you see here, you can see that capital K without this degree symbol, this symbol is not there in Kelvin, that is thermodynamic temperature in SI, but both are Ks. But when you put it itself without any bracket, that's for the unit Kelvin, SI unit of temperature. But while I put this in square bracket, it means the dimension of temperature, that's different. So see, this way we can have also the other quantities like electric current and so on. But you remain focused now in mechanical part, mechanics of physics, and you mainly use three dimensions, base quantities, M, L, and T, as you can see here. We shall need mainly the dimensions of three base quantities, that is for length, and then mass, and then for time. In thermal physics, we might require this K also, that is for temperature. So my next question is how to find the dimensions of derived quantities. Derived quantities are those which can be found by two or more base quantities through a particular physical law. Like for example, let's take the case of a simple case. Velocity is a derived quantity because it is defined to be the distance traveled in a straight line divided by the time interval. So you see that if we go for the dimension, this is of course v is the velocity. I'm treating it in one dimension, that is in a straight line. So if you want to find the dimension of v, you can write like this. This you can find by finding the dimension of length, that is distance traveled in a straight line, by the dimension of delta t, that is the time interval, and that you already know the distance dimension is L and the dimension of time is capital T in square bracket, so it's coming out to be L into t to the power minus 1. I could write also like this if we consider that MLT. These are the three main dimensions of the base quantities for mass, length, and time. It's also sometimes written as m to the power 0, L t to the power minus 1. So you note here that eventually you could write separately this dimension of velocity is m to the power 0, L to the power 1, that is t to the power minus 1. So you have seen here This is called the dimensional formula of velocity, a derived quantity which is found by making use of the dimensions of the base quantities involved in defined velocity. So here you can see the power of m is 0, power of L is 1, and power of t is -1, and this thing is known as the dimensional formula of velocity. Next, let us find out the dimensional formula of acceleration. Now, acceleration, for all these cases, you need to actually know this physical formula that relates the quantity to some other base quantities. Like acceleration, if I say that is defined in kinematics, that is the study of motion, to be the rate of change of velocity with time. Delta here standing for change in velocity, that is delta v. Change, that is delta symbol, is like a triangle. Delta t means change in time. So keeping this in mind, we can find out that the dimensional formula of A must be dimensional formula of v, because delta v and delta t, they have the same dimensions as v and t respectively. Whatever be the dimensional formula of v, that's also dimensional formula of delta v. Similarly, t and delta t should have the same dimensions, and we know them. Let me proceed. This is the dimensional formula of t. Now, here we put dimensional formula v is, I already got above, L into t to the power -1. We just now got it here. And then you put the dimensional formula of time, that is capital T, and combining them we get, this is coming out to be L into t to the power -2. We should never forget about putting this square bracket thing, and that's the dimensional formula of A. So we have shown the two findings so far. We can see here this is the dimensional formula of velocity, that is m to the power 0, L to the power 1, t to the...
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.